It is another nostalgic ramble about the mathematics of the high school with one of the clumsiest maths teachers alive. I like to think of it as a strength because being clumsy means I go really slowly through stuff. So hopefully there's an audience for that out there somewhere. Right, we are within the IEB May 2023 paper 2, and today we're looking at question 12. Let's get into it. So the question says the equation of the circle with center P is given as x squared minus 14x plus y squared minus 2y is equal to negative 46. Determine the center and radius of the circle with center P. Okay, so this is pretty much somewhere level 1, level 2 question, right? So straightforward textbook style question, right? We are going to use a method of completing the square because what we want is we want the equation to look like this, because once it looks like that, we then know that the center of the circle will be A, B, and the radius will be R. So we want to get this equation to look like that. Righties, so let's go about it. First, let's just put that in a corner. Let's try that again. Alright, we're just going to put that as a guiding light somewhere in a corner. Right. So we have x squared minus 14x plus y squared minus 2y is equal to negative 46. So we're going to complete the square for x and we're going to complete the square for y. Okay, so in order to complete the square, we are going to add half of this squared. Okay, and I'm just going to add it on this side as well, right? Because then our equation is still in balance, right? And then we've got y squared minus 2y plus half of negative 2 squared. But then we have to add it on the other side as well. Right, so then we can straight away put this into squared form. So this will be x plus the result of what's inside that bracket. So x minus 7 squared, right? And over here we'll have y minus 1. Okay, that becomes a minus 1. So, right. And then on this side, I am on good terms with my calculator again, so I will make use of it. We got minus 46 plus, and I'm still sick. Negative 14 over 2 squared plus negative 2 over 2 squared. So that becomes 4. Right, let's see if we can hide it successfully. Yes! I'm becoming a maestro. Okay, so now we have successfully managed to get our equation to look like the desired form, right? So we've got x minus 7, so that means the center P has coordinates 7, and then y minus 1, so the y coordinate will be 1. Right, and then the radius is the square root of 4, right, which is 2. And let's check the memo. Right, center 7, 1, radius 2 units. Perfecto. Forward we go. So, right, looking at the same circle still, we are told there is a point 6 and root 3 plus 1 which lies on the circle, and you can verify this yourself, right? You can verify it by taking x is equal to 6 and y is equal to root 3 plus 1, substituting it into, well, more specifically, substituting it into the left-hand side of the equation and seeing if you do in fact get negative 6. Or if you want to use the form that we worked out previously, you could put it in here as well. Put your x is equal to 6 and your y is equal to root 3 plus 1 into the expression on the left hand side and see if you get 4. Right, but there is no need, at least not yet. We trust the examiners. Right, so they tell you that this point does in fact lie on the circle. Awesome. Then you're asked to determine the equation of the tangent to the circle at A. I always love to draw a bit of a picture so that I get a sense of what to expect from my answer. It also reminds me how to work out the equation of a tangent. Okay, so let's draw that real quick. Right, so we've got, maybe let's not draw it so close to the question so that we can move it. Right, so we've got a circle whose center is 7 and 1, so let's say somewhere there is our center P. Is there a way for me to draw a shape? That would be so epic, but it does not look like there is. Anyway, forward we go. Just gonna have to trust my shady abilities. The radius of the circle is 2. Okay, so wait, let's just label that this is 7 and this is 1. So, right, this is going to be 2 units and 2 units that way and 2 units that way and 2 units this way is going to come, well, okay, right. It's gonna go below. Okay, so it's not really giving circle, but let's just believe. Right? So my circle looks something like that. Okay, and then we've got this point 6 and root 3 plus 1. So that's going to be somewhere here, right? Because our center is at 7, 1. So, right, our tangent is going to be something like that. Potentially. Okay, so I'm kind of expecting something with a positive gradient. Yeah, okay, cool. So how are we going to work out the equation of the tangent? This is also pretty standard. I've just forgotten how to do it, but I know that it's a very standard question. So watch me weep, watch me nay. Okay, so I think that we have to first find the gradient of this radius, right? And then we can use the fact that these are perpendicular because of tan rad to then find the gradient of the tangent. And then from there, because we know this point, we can sub it into the equation of the straight line and we can find what C is. Okay, awesome. Right, so let's start by finding the gradient. Oh, I don't really vibe with this orange. So we're going to find the gradient of MPA, that little radius. So that's going to be, let's say, root 3 plus 1 minus the y coordinate of P, which is 1. And in the denominator, we have 6 minus 7, the x coordinate of P. So that ends up being root 3 divided by negative 1, which is negative root 3. Ah, nice. Okay, so then we then know that the gradient, how shall we say this? Okay, so we know that the tangent is perpendicular to PA, right? and that's because of tan rad, that tan rad theorem. And so therefore, the gradient of the tangent is going to be the negated reciprocal. Wow, I spat on my tablet. Oh, the horror. Anyway, it's going to be the negated reciprocal of this guy, of the gradient of the radius. So that will be positive 1 over root 3. For those of you who are very fussy about rational denominators, that is the same as root 3 over 3. Okay, right. And so we now know that the equation of the tangent will be something like y is equal to root 3 over 3x plus c. And now we need to figure out what c is. Okay, and we do that by subbing in the point, what was it, a, which has root 3 plus 1 as the y, and then the x is 6. Okay, so now we've got root 3 plus 1 is equal to 2 root 3 plus c, right? And then c will be root 3 plus 1 minus 2 root 3. So that would be 1 minus root 3. Okay, and so in conclusion, y is equal to root 3 over 3x plus 1 minus root 3. Yeah, such a weird looking little equation. Anyway, it is what it is. That's the answer I get. Let's see what the memo says. So we have y. Oh, they don't care about rational roots. Oh no. Rational denominator, sorry. Y is equal to 1 over root 3, which is the same as root 3 over 3, x plus 1 minus root 3. Perfecto. Right, so I believe that the last bit of this question is the chunky chunk. I'm also just going to write here the equation of the circle, which I should have done for the previous one as well. I just kind of relied on us remembering what the x and y coordinate of the center is and the length of the radius. I'm about to sneeze, so I'm starting to sound a bit funny. Right, okay, so the question says, consider the point 8 and negative root 3 plus 1. Does point B lie on the circle? Okay, so instinctively, my approach would be to put it into, put in pretty much what I explained for the previous one. Put the point into the equation and see if the equation works, right? So let's do that. So sub B into LHS, right? So then the left-hand side of the equation will be equal to 8 minus 7 squared plus negative root 3 plus 1 minus 1 squared. I was going to put this into the calculator, but the numbers look quite nice. So we have 1 squared here, over here, plus 1 minus 1. Those two cancel out. So then we're just left with negative root 3 squared. So that's 1 plus 3, which is equal to 4, which is equal to the right-hand side. And so therefore you have to state the conclusion. So yes, point B does lie on the circle. Right. And then we are asked, is AB the diameter of the circle? Okay, so again, I would like my diagram. Give me my diagram. I am not going to draw it again. I will simply copy this one, which has become very messy though. Anyway. Okay. Let's copy it, right? And let's paste it. Oh, golly. There we go. Okay. Right. So, let's rub stuff out. Okay. So we've got A over here. And then we've got B, the point B, which is 8 and negative root 3 plus 1. So negative root 3 is negative 1 comma something, something, something. So this is a point somewhere here below the x-axis. So 8 and negative root 3 plus 1. Okay. So, okay, wait, just need to wake up my laptop. Right. So how could we prove that this is in fact the diameter or not? So let's kind of look at something that very obviously doesn't look like the diameter, right? So let's say B was somewhere here, right? So then this chord over here, well, first and foremost, can we agree that the diameter will always be the longest chord in the circle? Is that something we can take for granted? Intuitively, it feels true. Yeah, because if we think about it like in terms of trig, if you have a chord and then you draw a radius connecting the one end of the chord to the center and another one connecting what happened? The other end of the chord to the center, right? We know that this, you can kind of see that the length of this chord will be maximized when these are flat, i.e. when the chord goes through the center of the circle. Oh, that's such a sloppy explanation, but I don't know if it makes sense. I wish I had a more dynamic software where I could show what I'm trying to say. But I think it makes it makes sense, right? Like if you made a circle from pins, right? And then you put an elastic band. Okay, so this is, and then there's the center pin, right? And you put elastic bands around the pins, around 2 pins, and then around the center, right? This will be its longest when you wrap it around those guys, right? Like if you just imagine that makes sense visually. And I think again I'm laboring a point that is absolutely moot. But yes. So what was I saying? Oh, so all this to say, if we are to find the distance between A and B, and we are to find that distance is the same as 2 radii, then we know that AB is in fact a diameter. Yo, that was all over the place. And did it need to be? Did it need to be? Yes, it did need to be. But I do feel like Yeah, I think again, like just visually, this is pretty similar to another video that we did for an earlier question on this paper. No, yes, on this paper, it was a Euclidean geometry paper. We were talking about, um, yeah, let me not give all of that context, but pretty much what it came to was, if you imagined that there is a chord in the circle that is equal to the diameter's length or longer, then you don't actually end up with a circle anymore. You're going to end up with some egg looking shape where the center of the circle is here, but there's this chord that's longer than the diameter of the circle. Um, so, yeah, all of that messy reasoning to say, um, typically every other chord in the circle, so a line joining 2 points on the circumference, will be shorter than the diameter. So if we find that the distance between 2 points on the circumference is equal to 2 radii, then we know that chord must be the diameter. Of course, I'm going to go and think about this some more and think about whether there is a nicer way to explain this. And again, calling on everybody watching, just what's a nice succinct way that you would explain this whole idea. And I hope that it is an idea that makes sense. Yeah, because I'm not actually sure how else. I mean, I guess another way that we could prove it, but this would really be laborious, would be to show if AP, if AP plus PB is equal to AB, then we know that A, P, and B are collinear, right? They're on the same line, and B, AB passes through P, right? And again, that kind of makes sense to me just visually, but I don't know if there's some kind of a theorem that backs that up. Okay, right. I promise to think about this some more and come back with a bit of a concrete thought. I'll also look at the memo at the end of this video and see how they reason about it. But in the meantime, what I am going to proceed with is to work out what is the value of, and actually what I just said is actually the same as the previous thought, right? Because we do know what the size of AP and PB are because they are radii. We know that they're both going to be 2 units long. So, if we find that AB is 4 units long, then we can confidently say that AB is the diameter of the circle. Okay, wow, let's get into it. So AB is equal to distance formula. So root 3 plus 1 minus root 3 plus 1 squared. And then our x coordinates 6 minus 8 squared. Right, so we have got root 3 plus 1 plus root 3 minus 1 squared, and here we've got 4. And then we have 2 root 3 squared plus 4. Oh, it's a bit of an eager square root. Okay. Right. So that ends up being 4 times 3, which is 12, plus 4, which is the square root of 16, which is in fact 4 units. Right. Which is equal to the length of AP plus PB. Therefore, AB is collinear with P and is A, not D, many diameters, is a diameter of the circle. Oh, there's actually a better way. Oh, speaking of collinearity, this is actually, oh my god, this is actually, I think this is actually a better way to go about this. So collinearity is, we can calculate collinearity by finding the gradient of this line, the gradient of that line, and if those gradients are the same, then that means that A, P, and B are on the same line. Okay, that's actually a much better way to go about this. So alternative approach, much more confident approach. MAP, we already found what that was, right? We found that that was the square root of 3, negative square root 3, right? And then now we can find the gradient of PB, which is, so we know that P is 7 and 1. So 1, no, okay. I'm going to start with the negative 3 plus 1 minus 1 divided by 8 minus 7. So that's going to be negative root 3. And over here we have the 1, which is negative root 3. And so what we've shown is that the gradients are the same. MAP is the same as MPB. And therefore A, P, and B are collinear, right? And then same conclusion as before. So AB is a diameter of the circle. So let's have a look at what the memo did. So, oh, they actually did the distance route. Okay, so they just said, yeah, the distance between A and B is 4, which is twice the radius, and therefore AB is a diameter. Nice and clean. All right, but either approach perfectly valid. I'm more comfortable with the gradient. I think that also actually makes a lot more sense to my brain, to the visuals in my brain. But the distance also is completely fine, and I feel like, okay, I don't want to invest any more time in trying to polish up what is actually quite a simple idea. Like even the memo is just like, come on, it is what it is. But yeah, if anyone else does want to kind of give a nice visual explanation of why that is true, if AP plus PB is equal to AP, then they are collinear. Please make something, write us something, and share with the community, which is currently a community of 6 subscribers. But yes, share with us. Cool stuff.